Welcome back. So before the break, we were revising our trigonometry rules using some exam type questions. Let's continue with that. Okay, in this example, they've given us ABCD is a cyclic quad, and DC is 6 units, AD is 10 units, and D equals to 100 units, 100 degrees. And they've given us angle CAB, which is this little angle here, is 40 degrees. Okay, and in this example, we've usually been working through 2 decimal places. We're going to be working through 1 decimal places. They want us to find the answers correct to 1 decimal place. So they want us to find the length of BC, and they want us to find the area of ABC. When we're given an example like this, so we know we're doing trigonometry, but suddenly we see a circle. So we got to remember our circle geometry. So that's a clue that we're probably going to use some kind of circle geometry. And because we have a cyclic quad here, you have to remember some of the rules for cyclic quads. So what can you remember about cyclic quads from geometry? 2 important things we've got to remember. The first one is that opposite angles of a cyclic quad are supplementary, which is probably what we're going to end up using here. The other thing that we could possibly use, not in this case though, but is that the exterior angle of a cyclic quad is equal to the interior opposite angle. Let's see how we're going to use that information of geometry to solve this trig problem. Okay, so we need to find the length of BC. Now, again, we're going to examine our triangles. Remember, if it's a non-right angle triangle, we need 3 bits of information to solve it. So if we look at triangle ADC, we've got 3 bits of information. We've got 2 sides and an included angle. So we kind of have a V pattern here. And remember, if we have a V pattern, side, angle, side, we probably can use the cos rule. But we are being asked to find something in this triangle. We want to find the value of BC. But in this triangle, we have only 1 bit of information. We've only got this 40 degrees, which means somehow we need to find 2 other bits of information. So clearly we can see if we find AC, we've got 1 more piece to this puzzle of this triangle here. But clearly we need to find something else beside it. So it's easy, we could use AC. To find AC, we could use the cos rule. We understand that, we could use the cos rule in ADC. But what's the other bit of information we need to find? Again, remember I told you, why did they put this quadrilateral in a circle? Because they expect us to use Euclidean geometry to solve it. So remember, this angle is 100. So already we know we can find the value of B, can't we? Because those 2 angles, B and D, need to be supplementary. Okay, so first let's find AC squared. So AC squared is equal to, remember we're going to use our sides, so it's going to be 10 squared, right? So it's that side. And then this side, so 6 squared minus 2 times 10 times 6 times cos of the angle in between, which is 100 degrees. Okay, so if we put that into the calculator, we're going to end up with AC squared being 156,83778 and continuing like that. Again, remember, we cannot round off at this point because we need to get to the final answer. They wanted us to find the length of BC, so we've got to keep all this in our calculator's memory because we need to use this unrounded answer in the next step. So AC will be about 12,5 units. We need to find BC, because they did say we could round it off to 1 unit. We need to find BC, we can use our second triangle, and we already said that the angle B has to be supplementary, so we know B, because that was 100 degrees, B will now just be 80 degrees because it's the opposite angle of a cyclic quad, because together we needed them to be 180 degrees. Okay, so now we're going to use the sine rule in triangle ABC because it's exactly what we were trying to do. Okay, so now remember we want to find BC and we're going to use the sine of the angle across it, so sine of 40. And then because we have AC, it's what we found earlier here, we're going to say AC over the sine of the angle across it. And what did we say was the angle across from C? It was 80 degrees. Okay, we've got to do a bit of rearranging to try and get our answer. So we're going to say BC over sine 40 equals AC over sine 80. And remember, you have this answer in your calculator's memory still. So when you're doing this calculation, put it in, and then you're going to get a value for BC. Once you put this into your calculator, 12.5 times sine of 40 over sine of 80, and you should end up with BC is equal to 8,2 units. Okay, so that question has now been answered. Let's go to the next question. Okay, they want us to find the area of ABC. So to find the area of ABC, remember already we've got an expression for AC. Okay, we found AC earlier, and we found BC. Okay, and we found that this angle was 80. Okay, so if we want to use area rule, we want to try and use this V pattern, which means we need to find this angle. Then we have side, angle, side. Remember, for area rule, you need side, angle, side. So we've got two sides. Because we have the other two angles, we can find the included angle. So we can find that angle quite easily by just subtracting the other two from 180 degrees. So let's do that calculation quickly. So angle ACB will equal to 180 degrees minus 40 degrees minus 80 degrees, and we're going to end up with it being 60 degrees. Okay, and that's just by doing the sum of angles in triangle ABC. Okay, now to plug in our values into our area rule. Remember, area is equal to half AC times BC. So it was AC, okay, times BC times sine of the angle in between, and the angle in between we just found to be sine of 60 degrees. Okay, so plugging in our values. Earlier we found AC to be 12.5. We found BC to be 8.2 earlier. And so we plug in those values that we found earlier. All that's left to do is put this into our calculator, which is pretty straightforward. And look at the answer that we're given. And remember, it's our units squared. So our answer is 44,4 units squared. And that's the value for our area of our triangle ABC. Okay, let's go to our next example. In this example, we've got a triangular park, and we've got represented by PQS. R is a point such that they've given us values for R is a point on a line SP such that QR divides the area of the park into two triangular parks. PQ is equal to PR, which is equal to X. So those two are both X, meaning those two lines are equal. Remember, if those two lines are equal, we have an isosceles triangle making that angle equal to that angle. Okay, they give us the value for RS, and they give us the value for RQ being √3 X units, so that one. Okay, and they want us to calculate first the size of P, and then the area of the triangle QRS in terms of X. Okay, so because they want us to calculate the size of P, you will notice that in this triangle, we've given 3 sides. We've got 1, 2, 3 sides. So we're going to use the cos rule to find the size of P. And how do we do that? Because we want to find the size of P, we're going to start off with the side across it when we're writing the cos rule. So we're going to start off by saying QR squared. So when we begin our cos rule, we're going to say QR squared, so that one, equals, and we're going to use now the other 2 side squares in our cos rule formula. So it's going to be X squared plus X squared. So it's going to be, it's going to be PQ squared plus PR squared minus 2PQ PR. And remember, because we started off with QR, we're going to end off with the angle across from QR, P, because that's what we want to find. Now what's left is to just substitute the actual values that we have or the variables that we have. So we're going to end up doing that. So QR squared is going to be √3 X squared. PQ squared is going to be X squared, X squared. We're going to put an X in there, we're going to put an X in there, and remember we want to find P. Okay, we're going to do a bit of algebra now quickly. So we're going to basically take this 2x, this becomes x squared. We're going to take it onto this side, so it'll become positive 2x squared cos P and we're going to take this expression, square it out, and take it onto that side. Okay, we just clean up some algebra here, because remember we want to solve for cos of p, so it means I got to get rid of this 2x squared. I put the 2x squared into the denominator, and now we have an expression for cos of p, but remember I want to clean it up a bit still, so I want to do some algebra, and I notice I have some like terms here, so I can add the terms. Okay, and if you notice that you're going to have x squared plus x squared, and if you did the algebra on minus root of 3 squared, you're going to end up with 3. Okay, so you ended up with x squared plus x squared minus 3x squared, and that's how we ended up with minus x squared in the numerator here. And our denominator was 2x squared, and now we can just cancel out the x squared, so we're going to end up with cos of p equals to negative a half. Now remember, they wanted us to find the size of p, so we need to use our calculator and use the shift button. So we're going to say shift cos of negative a half, and the answer that we'll get is 120 degrees. So it means that this angle here is now 120 degrees. Okay, one more question on this. They've asked us to find the area of the triangle QRS in terms of x. So we need to find the area of this triangle here, QRS, in terms of x. And if you notice already, we've got one side and we've got two sides. So we're going to try and make a plane to get some other information. Okay, so we're going to be finding, earlier we found out that this was 120 degrees. So because that's 120 degrees, if I wanted to find these angles, because remember we said they were equal, I had to say 180 degrees minus 120 divided by 2, and I would find out that each of these angles, Q2 and R2, is simply 30 degrees. And how do we know they're 30 degrees? Because of angles, sum of angles of a triangle. Okay, that's pretty standard grade 9 work. Okay, remember we're finding the area, so we've got to find this angle here. We were looking for this angle here. So how do we find R1? Because it's adjacent supplementary angles, we just subtract 30 from it. Okay, so our area of QRS is going to be half QR times RS times sine of R1. And remember, we just got to substitute the values in, substituting the values in for QR and RS. And remember, we found R1 to be 150. Just clean up some of the algebra. And we're going to end up with, if you put it into our calculator, we're going to end up with 0.6495 x squared. So roughly, our area for our triangle QRS is going to be 0.65 x squared.